Hi everyone. This series of videos is going to take you through pages 23 and 24 in the packet, which is all about transforming sine graphs. If you watched the previous series of videos and completed pages 21 and 22, you've already kind of seen how sine graphs look. Sine graphs are the graphs that look like kind of a wave shape. And today we're going to talk about what happens when you move their starting point, which we were calling at that time 0, 0, to different locations. If you haven't yet completed those videos or those pages, I do suggest that you do so and then really take the time to check your answers and make sense of things before pursuing any of the videos and problems on pages 23 and 24. As always, if you feel like you get the hang of this stuff, or if you feel like you don't really need to watch the video in order to understand how to do the problems, feel free to skip the videos and simply do the pages on your own. The answer keys are posted on the learning plan as well as on my website, and I always encourage you to work ahead or work at least with what resources you need and ignore the ones that you don't. It's not mandatory to watch these videos, but these videos will help walk you through some of the questions in case you're really not sure what they're asking or what exactly you're supposed to do. We'll start this video with question number 1 in the hopes that we'll sort of break down the page and do little chunks at a time. In question number 1, we're going to start with the familiar territory of y equals sine x. That was the graph that we explored a lot on the previous page. And that was the graph that we feel, hopefully, that we have a pretty good foundation of. That's the one that starts at 0, 0, and then goes up, and then back, and then down, and then back. So now that we're kind of starting in familiar territory, hopefully filling in the table of values isn't going to be terribly difficult. Now, if you want to, you can always flip back to page 22 and simply copy the values that you already had in a previous table, or you can just do some quick mental math in order to figure out the values that we need. Now, as a quick disclaimer, if you don't have a unit circle somewhere handy, you might want to grab one because the unit circle can end up being a really helpful resource just as a quick reference source, if nothing else, so that you can use it just in case it's asking about a point that you can't quite visualize. If you wanted to look at it, for example, then sine of x at x equals 0 means I'm just finding sine of 0. That's the height of 0, which would be 0. Then it wants us to do sine of pi over 2. Pi over 2 is here. Sine is vertical, so that's the full radius. That's 1. Then we have sine of pi. Pi is over here. The height at that point is 0. Then we have 3 pi over 2. 3 pi over 2 is down here, so the height of that is the full radius down. That's negative 1. And then the sine or the height at 2 pi is back to 0 again. If you recognize this pattern from yesterday, this was the same pattern of the y-coordinates that we saw before. And perhaps once we graph it, you'll recognize that pattern of y-coordinates again. We start at 0, then we go up to 1, then back to 0, then down 1, and then back to 0. So it creates that little wave shape again. So I'll just leave that there as kind of a quick reminder of what the shape looks like so that when we make transformations today and we move it around a little bit, we can understand what exactly the graph was supposed to look like to begin with. Now in question number 2, it says, question letter A, it says, how would the table in question number 1 be affected if the equation was changed to sine x plus 2? So let's assume, just for reference sake, that we do think about that possibility. What if it was sine of x plus 2? Now you can almost pretend as if the table is being extended a little bit, and that it's almost like we're creating a new situation. Sine of x plus 2 means taking our answer from the previous sine of x and adding 2 to it. So, for instance, if the previous answer I got for 0 was 0, adding 2 to it would give me 2. If I take the next previous answer, I got 1. 1 plus 2 would be 3. Then the next answer was 0. 0 plus 2 would be 2. Then the next answer would be negative 1. Negative 1 plus 2 is 1. And 0 plus 2, again, is 2. So in theory, nothing crazy really happened. I just added 2 to all of the answers that I previously got. They just increased by 2. So you don't necessarily have to write anything super revolutionary for letter A. All that's going to happen is that the y-coordinates increase by 2. I'll write some of these answers. In other cases, I'll say the answers. And hopefully, as I'm saying things, you can pause videos, you can write things, or you can put them into your own words. Now, in letter B, it says, using your observations from A, fill in the table and sketch a graph of the equation sine x plus 2. Now, good news for us, we already have the numbers for the table, so I'll just quickly transfer those over. That's 2, 3, 2, 1, and 2. So those are my new numbers. And now I'm going to plot those new numbers on the graph. Now 0, 2 would be 0 and then up 2. We're using the tick marks that are labeled for us there. Then pi over 2 and 3. Pi 2. This is starting to look like a familiar pattern. That's good. 3 pi over 2 is at 1. And 2 pi is back at 2 again. And sure enough, when I connect the dots, it definitely does look like the graph that I'd already seen. It definitely has that wave pattern where we go up and back. Now, if I wanted to repeat the pattern, I definitely could do that. After I get back to 0, or in this case, the starting value, I can repeat the pattern. So the next tick mark must be up, the next tick mark must be back to the center again, then down, and then back to the center again. You could even extend the pattern backwards. If you were going backwards through all these dots, the dot before 0 at negative pi over 2 would be down and then back to center again. So you can definitely do as many dots or as few dots as you feel like you need in order to get the idea. But let's go ahead and connect the dots, and to go one step further to give us a better visual, let's also highlight what the first dot we plotted originally was, because sometimes it gets a little bit lost after you make so many other dots and connections. And let's look at that highlighted point, because it says in letter C, what effect did the plus 2 have on the graph? And how is that related to other graphs we've seen before? Well, if I just have a quick comparison, I can see that the yellow dot here is at 0, 2 as coordinates. And previously, the starting dot that I made was at 0, 0. So I can tell that while the shape is still the same, it goes up and down and up, that whole thing hasn't changed, but the location of the starting point definitely shifted. It used to be at 0, 0, and now it's at 0, 2, which means it shifted the graph up 2. Now, when you do think about this, hopefully you'll start to say to yourself, oh, that makes sense. Because if the equation has a plus 2 in it, and specifically the plus 2 appears after the parentheses, that might remind you of other graphs that we've seen that have a similar sort of shift. For example, parabolas shift the exact same way. A parabola equation has this extra number at the end of the equation, we used to call it the k value, that would shift a graph up. If it was a minus, then we would shift the graph down. So that k value does remind us of other graphs we've seen before, like parabolas and all the other shapes we've studied this year. So if we were to make a hypothesis, let's make a guess. It says, how would the table in question number 1 be affected if the equation was changed to y equals sine x minus 1? So think a little bit logically for a second. If the plus 2 shifted the graph up 2, think about it. What do you think the minus 1 would do to the graph? I'll give you a few seconds to think about it, and then I'll tell you what I think and we can compare. Did you predict that the graph would shift down 1? Because that's my prediction. My prediction is that the graph is going to shift down, because if plus shifted the graph up, then logically it seems like minus would shift the graph down. And if the number itself tells you how far up, then the 1 must tip me off that it's going 1 unit down. So that's my hypothesis, but let's see if that's actually going to come out to be true. In letter E, it says fill in the table and sketch the graph for the minus 1 version of things. Now I'm going to go back for a second to my original coordinates, because if all of these coordinates are just minus 1, compared to the originals, then I'm not going to reinvent the wheel. I'm just going to subtract 1 from everything. So if this first coordinate was 0, 0 minus 1 is negative 1. If the next coordinate was 1, 1 minus 1 is 0. So I'm just doing minus 1 off of everything. The next coordinate was 0, 0 minus 1 is negative 1. The next coordinate was negative 1, negative 1 minus 1 is negative 2. And the last coordinate was 0, so 0 minus 1 is negative 1 again. Now I'm going to plot those points. So 0, negative 1, pi over 2, 0, pi, negative 1, 3 pi over 2, negative 2, and 2 pi, negative 1. You'll notice I graphed kind of quickly, but only because I want to make sure that we have a chance to just kind of see the pattern emerge. And if you need to, you can always pause the video at any time so you can catch up, especially if it takes you a little bit longer to plot the points. Now again, when I connect the dots, I see the same wave pattern, and I can continue the pattern further just so that way I can see more of the dots. And I can also extend the pattern backwards if I want to see more dots that way. It's not mandatory to do that part, but it might be kind of helpful for those of us who want to see the pattern continue on. Now, let's take a look quickly, if we can, and see if we can make some sense of what we just did. If we go back and think about the first point that we plotted again, that was at 0, negative 1, and that was this coordinate here. And again, I'm going to think comparatively. Remember how on the previous page, the starting dot was always at 0, 0. Now here we are with our starting dot at 0, negative 1. Well, comparatively, that is definitely 1 unit down from the original starting point that we were using yesterday. So sure enough, it seems as though our prediction is true. The minus 1 really did seem to shift the graph down 1. So we can probably make the conclusion then that all of these plus or minus numbers after the equation are going to shift the entire starting point up or down, depending on whether that number is positive or negative. So if we can think about that for a moment, let's consider in question number 2 how to make a prediction about that graph. I'm going to do question number 2, and then this video will end with you doing question number 3 on your own. So I'll talk through all the necessary logic here to make sure that we understand what to do, and then you'll try question number 3 as kind of a check for understanding. So in question number 2 it says graph this equation. Now this number in the front reminds me of that radius situation that we saw in the previous set of videos. The radius is also the height of the hill. So that 0.5 is telling me that the graph is going to go up half of a unit from the starting point. Remember, this tells us essentially the distance to travel as we're going up and down these little hills. We didn't really talk about that in the problem that we just finished, but it was because we were plotting points and we weren't really thinking about looking at the equation. If we go back and look at the equation though, hopefully it does make sense why we did what we did. This equation and all of the equations that we were graphing had an invisible but definitely present 1 in the front. And that 1 in the front would have told us that from our starting dot we were going up 1 full unit to get to the top of the hill. The same thing would have been true of all the other equations that we already did. There was a 1 in front that we couldn't see but was definitely there, and that again was telling us to go up 1 full unit to get to the next dot. So this equation is going to tell us from our starting dot to go up, because it's a positive, 0.5 units to get to our next dot. So that's going to be important information, but we have to know where to start. And that's where this plus 1 is giving me a hint. If by default I start at 0, 0, but that plus 1 is saying, no, 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 shift yourself, then I'm going to shift the graph up, because it's positive, 1 unit. So instead of 0, 0, I'm going to shift up 1, and I'll make my starting dot there. You can highlight your starting dot if you want to, or you can just kind of make a mental note that that's where you're starting. Now that I'm there, I'll create the rest of the graph. Remember how a moment ago we said that the next point was going to be half a unit or 0.5 units up from the start? That's telling me what to do when I get to my next major tick mark. So at my next major tick mark, I'm going to go up 1 and make my next dot. Now the pattern is going to repeat itself, which means we can recycle the pattern that we've seen in these other graphs. After you go up 1, then at the next major tick mark, you go back to where you started again. Then you'll go down 1, or sorry, I keep saying 1, up 0.5, then back to where you started. Then down 0.5, and back to where you started. So you just kind of have to pay attention to the pattern, but notice it is always the same pattern. Up, and then back to where you started, then down, and back to where you started. You can connect those dots, and that would be one cycle of the graph. It is usually a good idea, if possible, to continue the pattern and try to create more cycles just to complete a full picture, as well as to go backwards. It's not mandatory to do that, but you may find it to be a little bit helpful just to kind of complete the visual pattern. In any case, now that you've seen how exactly the shifting up or down is going to work, see if you can give question number 3 a try. I'll give you a hint that this number in the front is again telling you how far to go to get to your second dot. So it's almost like you need to read the equation backwards. The beginning of the process actually stems from the end of the equation. This is telling you where to shift your starting point, down 0.5. Then once you shift your starting point, the number in front tells you how far to go next, how far to go to get to your second dot, and how to make the pattern go. So between now and the time that you start the next video, finish question number 3, take some time to digest all this information and to check the answer using the answer key provided in the learning plan. In the next video, we'll do the bottom of the page and continue the ideas.